So if the current through R2 is 2.32 milliamps, and our total current is 6.1935, then the current through R3 will be the 6.19 minus the 2.32, right?
Yeah.
Okay, so we can add that up. So 2.32 enter 6.1935. Oops. Supposed to subtract. So current through R3 is about 3.873 milliamps. Everybody see that? So that means if we know the voltage is 58 volts and the current is 3 milliamps, what is the value of R3? It would be the voltage divided by the current. Something like 15K.
Yeah, 14.992K.
Yeah. Okay, so what didn't we solve for? Well, we didn't solve for the value of R1, right? Okay, so now R1. We know R1 has a current of 6.1935. We also know that voltage across R1 equals our source voltage, 120 volts, minus the voltage drop across either R2 or R3, because they're the same, minus 58.065 volts. So the voltage drop across R1 61.935 volts. So if the voltage drop across R1 is 61.935 and the current through R1 is 6.1935 milliamps, the resistance is voltage over current. So 61.935 divided by 6.1935 milliamps $10K. I think that's what the answer says. Yeah, $10K. Is that making sense on how I got that?
Yeah, I'm good.
Okay. How about you, Travis?
I'm just having a tough time with it tonight, so I'm pretty much useless.
Sorry, man. You know, I have days like that too. Sometimes I have whole months like that. All right, well, hope you shake it off by Monday, okay?
Yeah, I'm hoping to.
Okay, cool. Kelly Brunson, how are you doing? She's looking for the mute button. Okay. So that's number 1 and 2. How about if I work 3 and 4 now?
Okay.
Okay. Now, because it's sort of getting a little more complicated. Okay, I just work everything out on one piece of paper. Well, I can do it like this, maybe. Yeah. Okay, I just draw it out. Okay, we got VT, R1, R2, R3, and R4. Alright, so we know R1 is 4.0 4.9556K. R2 is 5.6K. R3 is 10K. And R4 is 8K. And IT, IT is 2 milliamps. Find everything else. Okay, cool. Put that there. So Frank, how would you proceed with this guy?
So, total current is 2 milliamps, right?
Yep.
So we know that coming all the way through, you just have to find out so the current, so R1 resistance is, so just add up the total resistance is what I would do.
Okay, so we want to find the total resistance. Okay, so the total resistance, when we got this 10K and 8K in parallel, right?
Yeah, so we have to find those out first.
Okay, let's go ahead and figure that out. 10K and 8K. $4.44K, something like that.
Yeah, 4.44K, yeah.
Okay, so then we can just add that to R2, right?
Yep. And to R1.
Yep, then R1.
And that'll give us the total resistance.
I got something like 15K.
And then we'll be able to find out the total voltage.
Yep. So if RT is 15K and IT equals 2 milliamps, VT equals 15K times 2 milliamps.
Yeah.
30 volts. Okay, R1, we know VR1, we don't know VR1. We know IR1 equals 2 milliamps, right? And R1 equals 4.9556K. So VR1 would be 4.9556K times 2 milliamps.
So, Jim, where did the 4.44K come from?
Oh, the 4.44K came from the 10K and 8K in parallel. So it's 1 over 8K plus 1 over 4K. I'm sorry, 8K and 10K. And that should come out to 4.44K.
Okay, all right. Gotcha.
Cool. So we figured out the voltage across R1 is 9.9112 volts, which is basically the 2 milliamps, which they told us, times the 4.9556K. So in that case, the voltage across R2, we know that IR2 is also 2 milliamps, right? Because all the current that goes through R1 also goes through R2. And since R2 is 5.6K, the voltage across R2 should be 2 milliamps times 5.6K.
Mm-hmm.
Or,
7.2.
yep, 11.2. So, if our total voltage is 30 volts, R1 drops 9.912, and R2 drops 11.2, what's left across R3 and R4? It would be 30 minus 9.9112 minus 11.2, right? Remember Kirchhoff's voltage law. You go around this loop, they have to add up to the source voltage.
30.
Yep. So the voltage across R3 and 4, I have 8.88 volts.
888, yeah.
Yep, 8.888 volts. So now, how much current is going through R3 and R4? Okay, so current through R3 equals 8.889 volts, and R3 is 10K divided by 10K. I got 888.89 microamps, right? Current through R3. So the current through R4 would be 8.889 volts divided by 8K. Yep.
Milliamp.
Yep. 1.111 milliamps. So if we add up 1.111 milliamps to 888.89 microamps, that should equal, sorry, my phone. That should equal 2 milliamps, our total current, right? So let's see. 888.89.
So yeah, basically 2 milliamps, yeah.
Yeah, I got 1.99999 something.
999, yeah, 8.
Yeah, 2. So that's basically that problem.
Okay.
And the only other part left to do is calculate power, and you can do that because we have, for everybody, resistance, voltage, and current. You can use, a lot of different formulas to get that.
Voltage times current would be easier.
Yeah. Okay, so that one wasn't so bad.
Yeah, I mean, once you, get the total, resistance, then it's a piece of cake.
Okay, let's do another one. How about number 5? He looks a little scary. Okay, let me redraw this one and we'll do it. I'm going to redraw a little differently. Same circuit, I just turn it over a little bit. Okay, now, we know IR4 is 9 milliamps, right? Okay, so that means total current is 9 milliamps. Everybody agree with that?
Yeah.
Okay. Okay, we also know the voltage across R3 is 6.9678, okay? The current through R2 is 4.6451 milliamps, okay? I should write this. So IR2 is 4.6451 milliamps. So if IR2 is 4.6451 milliamps, what's current through R1? It'd be the same, right?
Just take the 9, huh?
It'd be the same, because R1 and R2 are in series.
Yeah.
So whatever goes through R2 goes through R1, right?
Oh, that's right, yeah. See, okay.
So IR1 and IR2 are both 4.6541 milliamps. Now, IR3 will equal,
Parallel, so
it'll be 9 total current minus 4.6564, it'll be 9 milliamps total minus 4.6.
4.6451.
Exactly. Or about